Well, this is Nitin Dahad with EE Times. I'm here at the SM1 facility for Texas Instruments in the new fab, 300mm fab that's opened here this month. And I'm talking to Mike Haggerty, who's responsible for the Sherman fabs. Mike, hello, how are you?
Oh, I'm wonderful. Welcome to Sherman.
Thank you, and thank you for taking me around. We're going to talk a little bit about the stuff you're doing here, but basically, tell me about the importance of this for you.
Oh, so this role is an amazing role. We have the ability here at TI not just to go innovate in our technology, but also in our manufacturing, which is what I'm most passionate about here, is the manufacturing that we're doing with the team here in Sherman, Texas.
Okay, and I've spoken to your colleagues and Mohammed and all that, but in terms of the operation here, there's quite a lot goes on, and just for the readers and the viewers here, what's the output of Sherman? What's that going towards here? I mean, all the stuff we see going on here, what's it going towards?
So this is TI's first 300mm factory here in Sherman, Texas. It's part of our $60 billion investment in US manufacturing and wafer fabs. This factory will produce tens of millions of advanced analog and embedded processing chips every day as part of TI's expansion. But our chips here specifically go into essentially every application in electronics. We like to say if it plugs into the wall or has a battery, it very likely has at least one TI chip in it.
Right.
We're talking your toothbrush, the automobile you drove to get here. We're in life-saving medical applications. We're in refrigerators, satellites. The list goes on and on.
Okay.
Data centers, etc.
And this fab, SM1, is part of the four that you're planned over the next to the end of the decade, I guess, depending on how much capacity you'll need. This has been running for what, a couple of months already?
So the expansion over time will, of course, depend on market demand, but this factory is in production now.
Yeah.
And so in just over 3 years since breaking ground, we've built this factory and we put it into production.
Yeah, and so how much utilization have we got of this whole floor space? Because we had the ballroom, which we were in earlier, is about 30 to 50%, something like that.
So this factory is part of a modular capacity expansion strategy that we have.
Yeah.
And so as we have released this factory into production, we have lots of room to grow here in SM1. And then as SM1 starts filling up, we already have SM2, the second factory shell, already built. And
Which
one of
is
the important,
over there somewhere.
it's straight that way.
That way, yes.
And
yeah.
one of the important things with the design of this factory, though, is each of these four factories tie together and operate as one mega fab. And that's really important for our customers because we're essentially able to provide whatever capacity our customers need when they need it.
Now, we're going to talk about individual elements, but what's unique for you, for what you see, what you're doing here? What do you think is really special, what you're doing here?
So TI's been innovating in the technology and manufacturing space for decades. And one of the amazing things about this factory is we have taken all of those years of experience and knowledge and best practices, and we've brought them here. And so how TI has equipped this factory is exactly tailored to the technologies that we run and the products that we design and sell to our customers.
Yeah, we're standing here with some of the photolithography, but we're going to go into various areas, including epitaxy and others, aren't we?
Yeah, we're standing in the photolithography room, and this room is special because it houses all of our photo equipment.
Yeah.
Photolithography, of course, is ultimately how we get one of our designs built into the wafer. And this room essentially operates like a clean room inside of a clean room, where even the pressure, the air pressure inside this room, as an example, is higher than the rest of the fab. So air is always being blown out of this room to essentially control the air quality even more than other places of the fab because of how sensitive some of this equipment is.
Now, we're going to be talking, we're going to one of the other areas now. So Mike, one of the key outputs from Sherman and the new 300mm fab is obviously for the analog power and products, power and embedded products. And we're here in the doping area of the SM1. Tell me, what's the significance here?
So the significance of this room is what you're looking at behind us are implanters.
Yeah.
And so this is very specialized equipment in this advanced analog manufacturing site that takes very specific elements like boron and implants or injects it into the silicon at a very controlled rate. We have to control the depth. The elements and dopants that go into the silicon from this room then go into furnaces and get diffused, diffusion furnaces. And so how the dopants tie together, how they move through time and temp, all pieces together into what makes some of our analog chips very competitive and high performing. It's critical to the operation.
So I mean, you've got a whole line of equipment doing that here, and it's taking a lot of knowledge from what you've learned over the years?
Yeah, TI has been innovating in the manufacturing space for decades, and all of that learning has come here to Sherman, Texas for our 300 millimeter factory here. And the room that we're in now, the entire room is dedicated to just implanters. So all the equipment we have are injecting dopants into the wafer. A difference that a factory like a high volume analog factory would have to some other factories in the world is the number and amount of floor space that's dedicated just to implants. Right, so implant is incredibly important for advanced analog technologies.
All right. Well, okay, Mike, we'll move on to the next bit. Mike, we're in the Epitaxy area of SM1. Tell us what's going on here.
So epitaxy in an analog chip is one of the first layers we do. You can imagine if you're building a house, the foundation that everything sits on, that is epitaxy.
Yeah.
And so epitaxy is the first layer. What's unique about this equipment for TI is that we do all of our epitaxy in this factory in-house.
Yeah.
Epitaxy is important because it's where we take a silicon wafer and we grow a very precise silicon lattice on that wafer with specific doping characteristics, and then all of our initial components get built in that epitaxy layer and upon that layer.
Okay. So this is actually a very important part of that analog process.
Epitaxy is an important part of the analog process because it is some of the initial foundation that a lot of our components like transistors and some capacitors end up sitting in.
Yeah.
And in analog space, LDMOS is an example of a component that's very important for power delivery, high precision power delivery. It lives in the epitaxy, and the epitaxy is a critical part of that foundation.
So Mike, tell us what's going on here.
So behind us are examples of two different types of thin film. And so in semiconductor manufacturing, we go through hundreds and hundreds of steps just to create a single finished wafer. On our left is an example of chemical vapor deposition. On our right behind us is an example of physical vapor deposition. So both end up putting thin films down, measured at the nanometer level, onto a wafer. But they are examples of metals or oxides or TIOS as different types of thin films that are critical for the operation of our analog chips. For advanced analog and embedded processing, one of the critical care-abouts that we have to very precisely control and measure is the uniformity of thin film thickness, not only across a wafer, but also in very tight areas within a single chip. In an analog and embedded processing chip, tightly controlling those directly impacts how well we can control high precision applications, power delivery, battery monitoring, etc. that goes into all sorts of applications around the world.
And now tell me, I mean, we see the overhead like we see in most fabs these days, the FOUPs, the transport of the wafers, but you've also got storage and you're transporting further down the lines of reticles. Just tell us the whole story there.
So this is TI's newest 300 millimeter factory. It's here in Sherman, Texas. This factory is designed for advanced automation and is highly automated.
Yeah.
And so 100% of our material, our wafers that get moved around this factory do move around on the overhead track above us.
Yeah.
They travel together in a FOUP, like you said, a front opening unified pod. And 25 wafers will travel like a family step to step throughout a lifetime.
Yeah.
This factory also has fully automated reticle delivery. So our photolithography area, the reticles are moved through robotics. Another feature of this factory is how we store material when it's in between steps.
Yeah.
A lot of wafer fabs require like parking garages that have to sit here on the floor. The clean room floor is the most valuable space.
Yeah.
We eliminate all of those parking garages and we store all of our silicon when they're in between manufacturing steps up on the ceiling.
You can see it in this little black tray here.
Under track storage.
Under track storage. And that's basically improving the floor space, more efficiency, etc. Is that right?
Higher efficiency of the floor space, and that becomes really important because the more equipment we can fit in here and the more efficiently we can use the floor space, the more capacity a wafer factory like this can have.
Okay.
And that advanced automation comes with lots and lots of scheduling and innovation in how we move materials step to step. And it really does drive efficiency for the factory.
Okay. I mean, talking about automation efficiency, I guess you don't really need people in these sort of spaces apart from some maintenance, I guess.
So advanced factories like this, material movement is done through robotics.
Yeah.
We actually still require highly skilled, talented individuals, not just for maintenance, but also continue improving our equipment, also innovating in our processes that run here. And that's through technicians, through engineers, for example.
Well, Mike, thank you very much.
Thank you.
Thank you.